All right. So I found this website that I thought might help me to teach you guys how to find, given a graph, how to determine what is the function, the first derivative, and the second derivative. So I have this one up. I already did it. So I just want to explain how it's done, and then we'll do I'll just keep getting more for a few times, and hopefully that'll be enough so that you understand. So um, we we kind of want to start looking at the max and mins of functions. So the maximum and minimums of functions. So let's do that. Let me just write this down. Look for max and minimum. Okay. And wherever you have the max or a min of a function, basically the tangent line is always going to look like a straight line. And I know that's not right in the right place, but you understand what I mean. And it's going to be a horizontal line at the minimum. And the slope of that line is going to be 0, which is what the derivative is of a function. So what we want to do is first look and see. So if this point right here is the maximum, then one of these would have to be, if it was the derivative, it would have to be 0. So that is 0. Okay. So right now, it looks like the derivative of black is red. So let's continue on and just check. Here we have a positive slope, right? Everywhere there's a tangent line, there's a positive slope. So notice the red line, which I think is the derivative of black. It's positive until it gets to 0. And then on the other side of that maximum, notice that all the slopes of tangent lines would be negative. So if the derivative of black were red, starting at this point, all the values would be negative, and they are. So I know now that the derivative, so let me write it like this. Look for max and mins. The derivative will be 0. Okay. So I started there and I found that I think that let's do it like this, that the derivative of black, so if I have black, and I'm going to say the derivative of that, I'll just do it like this, or I could put D, black, whatever. So the derivative of black, I think, is red. Now we have to figure out, is black the derivative of something else, or is blue the derivative of red? Because it's either one or the other, right? Either blue is going to be here or blue is going to be here. And we just have to figure out if it's the derivative or not. So I look at my blue line, well, I look at my red line, and I do have a minimum here. So that means that should be 0, which it is. That's pretty good. And then what I want to notice also on this red line, the slope from here to the end of the graph, right? So from here to the end of the graph, the slope is always positive. I'm sorry, exactly the opposite of what I just said. The slope is always negative. And if you look at that blue line, it's negative until we get to that point. And then notice here, the slope becomes positive. It's increasing and the slope is positive. It's above the x-axis, which means it's positive. So now I know that the derivative of red is blue. So I can say that the derivative of red equals blue. So that means that black is the original function. Red is the derivative of black. So the derivative of black is red, and the derivative of red is blue. And then I just pick them over here on the side. If you want, you can play with this website too, if you really want more problems. But that's kind of how I did it. So now let's clear this and we'll get a new function. And we'll see if we can get it right. So, hold on. And at any point, you can just stop the video and see if you can pick it out. So I'm just going to start with the blue line. It doesn't really matter which one I start with. Okay, so if I start with the blue line, I started with the blue line because I don't know, I just like that it's got this minimum here. And that's 0. And then it's got like a maximum right here, and that's 0. So that means that the derivative of blue is black. And we can keep checking, like, notice how it's got a negative slope. There's another maximum here somewhere, which is why it's crossing at 0 again. And so the slope is positive until it gets to this 0, this minimum. And then okay, hold on. Let me just make sure I'm saying all this right. So we said that the derivative of blue is black. So that means that here should be a 0, and the derivative of blue. So here is the max. So here, there's the derivative is 0. Okay, the derivative of blue. So here I have a negative slope. From here all the way to here, the slope of the tangent line is negative, right? No matter where I put a line, that's a tangent line, so it's gonna be negative. So that means that black should be negative in all those places. And look, black is negative. It's below the x-axis all the way to this 0. So from here to here, the black line is negative. And then at this 0, it becomes positive, which is true of the graph, because all of a sudden the graph starts increasing. The blue graph starts increasing. That means the black line, which is the derivative, has to be positive. And then again, at that 0, it starts decreasing here. So from here to here, it's decreasing, which means that the derivative has to be negative. And notice the black line is below the x-axis, meaning it's negative. So I'm pretty sure, I'm actually positive that the derivative of blue is black. Now we just have to figure out where red comes in. So either red's going to be on this side or this side, right? So we can check to see if the derivative of black is red. So let's look at the black line. So the black line has a maximum right here. So that means red, well, red does not have a 0 there. So I know that the derivative of black is not red. This is not true. Now we just have to make sure that we have the red in the right place, which I would imagine we do, but we'll check. So we have a maximum here at this point here, and we're saying the derivative of that should be blue, and blue has a 0 there. We have a minimum right around here, and blue has a 0 there. Perfect. And we can continue to think about all these different things. So red is increasing to here. That means blue should be positive, and it is. From here to here, blue is positive because it's above the x-axis. We're not talking about the slope of both. We're talking about, so let me see if I can say this in a way you understand it. So the slope of the function at a point, well, let me even say it better. The slope of the tangent line at a point is the derivative. Okay, so if I were to make a tangent line, let's do red. I'll make a tangent line right here, this point. I pick a point. The tangent just hits that point hits that place at one point. And we can see that this has a positive slope. Just that line has a positive slope. And I said the derivative of red is equal to blue. So notice how blue in the y, as far as y is concerned, I have an idea. So blue from here to the 0, it's positive. And then red starts decreasing. So from here to here, the slope of any tangent line would be negative. And notice that the blue line is negative. Let me get another color here. The blue line is negative from, let's see, from here, sorry, to here. That's where the blue line is negative. It's below the x-axis. So does that match up with my function? Yes, those are the exact places I expected them to be negative. So we said the slope of the red line is negative from here to here. And notice if I just look at the blue line, it's below the x-axis from approximately -4, -3 point something to approximately 1 point something. And that is what I'm looking for. So I know now that red is the original function. The derivative of red is blue, and the derivative of blue is black. And let me check, make sure. Okay, we got it. Okay, let's do another one. My mouse. There it is. And let me clear this. I think I'll just clear this part because that's going to be true for each graph. So let's see. Let's pick up one of them. It doesn't really matter. Let's start with this right there. If I were to find this point, that's the max. If I were to follow it down, that is 0. So my guess right now is that red is the derivative of black, but let's check the minimum point, which is right here. This also has a horizontal tangent line. And oh, look, perfect, red is 0 there as well. So now I know that that the derivative of black is equal to red, right? Because I just showed you, and we could look, here we go, from here. So if I'm looking at black, from here to here, I'm increasing, which means the slope of any tangent line between those 2 points is going to be positive. Let's look at the red line from here to here. The red line is above not the slope, but the function is above the x-axis, which means that it's positive there. So that works. Notice then it gets negative from here to here. And if I look at the red line, it's below the x-axis, so it's negative that whole way. Okay? So I'm positive about the derivative of black is red. Now I have to find out where blue falls, right? So let's see. Blue is either going to be on this side or it's going to be on this side. So let's see if blue could be the derivative of red. I'm going to go this way. So let's see. Blue is the derivative of red. So red has a maximum right here, which means that if blue was the derivative, that would be 0. That worked. And red has a minimum here. Oh, look at that. That works for blue. And then we can look and make sure they're increasing and decreasing at the same parts. So I look at, so I think that blue is a derivative of red. So here we're increasing all the way to here. And notice I have above the x-axis till I get to that point. Then I'm decreasing. And that means I'm below the x-axis to here. And then that's 0. And then I'm increasing and I'm positive. So I know now that blue is going to be on the side up. So the derivative of red is blue. Okay, so I'll say derivative of red equals blue. Okay, and then let's check our answers. So that means that black has to be the original function. And the derivative, so the derivative of black is red. So that's the first derivative, excuse me. And the derivative of red is blue. So that's the second derivative. And we got it right. Okay. I think I'll do a few more because I know this can be a little complicated. So, but I'm going to keep saying the same things. So whenever you get it, you really did get it. There's nothing more I can say about it. All right, so let's do it again. Let's see. Okay, so let's start with black. And it doesn't really matter what you start with, honestly. But I just like that I got that maximum. That's just the maximum that jumped right out at me. So that means that the derivative of black could be red. Let's look at the minimum here. Yeah, I'm pretty sure it is red because I have 3 max and mins and they're all 0. Okay, so that means that black goes here and the derivative of black is equal to red. Okay. Now, I want to know, is blue on this side? Basically, I'm saying, is the derivative of blue black or is the derivative of red blue? So let's look at those two graphs together. Let's start on this side. So if blue is the original function, that would mean that here something should be 0. And it doesn't look like anything's 0 there. So I feel like, oh wait, I did it backwards, I think. Oh yeah, no, I did it the right way. So if blue is my original function, then the derivative should be black, but that derivative is not at 0, it's at negative. So that's not true. This is not here. We're just going to check, we're not going to assume. So we're going to check to see if the derivative of red, so this is a 0, this is a horizontal, the slope would be 0, and I have blue as a 0 there, that's good. And I have a minimum here, and I have blue as a 0, perfect. So I think it goes like this. So it goes black, and then the derivative of red is blue. And let's check. So that would mean black would be first, red would be second, and blue would be third. Check. And we got it right again. Okay. Okay, one more, and then we'll call it a day. All right, so it doesn't matter again where I start. Let's start with blue this time. So I look here, this is my minimum. I look up, there's a 0, good. There's a maximum up here and there's a 0. So I say the derivative of blue is equal to black, right? Hopefully that makes sense. And if we follow the rest of the rules, hold on, it's negative. So if the derivative of blue is black, that means here, this is a positive slope. And notice that black is above the x-axis. And then we have a negative slope until we get here. And notice we have negative values on black. And then we increase. And here it's all positive. And I guess that at that point, the blue would be coming down, and that's why it becomes negative. So I'm positive that we got that right. Now we have to figure out where red goes. Red's either going to go on this side or on this side, right? Either the derivative of red is blue or the derivative of black is red. I only have two choices. So let's try from red. So red, if I find the derivative of red, I'm going to look again at my maximum, and my maximum is here. So the blue line should be at 0, and it's not. So I know this can't be true. Let's make sure that the derivative of black is red. So black, there's my max, and red is 0. There's a min, and red is not 0. Derivative, oh, I'm sorry, black, red, black. Okay, sorry, I think I'm messed up. So the derivative of black, that means here we have another min. So the derivative of black is red, that's true. And yeah, and there's another max and there's another 0. Okay, that's looking very positive. And the derivative of black, so we look at here, my function is decreasing until I get to this point. And here, my function is negative because the slope, since it's decreasing, the slope of the tangent line is going to be negative. And then it changes. So I think I'll change colors here. So from here to here, this is increasing. And the tangent line is going to be positive. And notice from here to here, it's positive. And then again, from here to here, it's negative. And from here to the end, it's below the x-axis, so it's negative. So we have it in the right order. And I have the function f is blue. The derivative of blue is black, and the derivative of black is red. Check. That's it. So I think that's enough examples. If you have any more questions, feel free to ask. But I think I'm going to end the video here. Here's the website. Let me see if I can copy and paste it, make it a little bigger. Copy and, oh my God. Okay, I know what I can do. And we'll try to make it a little smaller. I don't know how to make it smaller. Oh. Oh, they don't want to let me text. What? Um, yeah, it looks like I can't make it smaller. I can try one more thing and then I give. Let's try text. And are they gonna give me, oh, I don't see any choices about size here. All right, well, I'll paste it back again. And let me make it. I think I can make it a little better. Well, I think that's the best I can do because I can't figure out how to make the font smaller. Let's try one more thing. No, select. Nope, I have no idea. Okay, so that ends the video. I'm sorry I couldn't make it a little smaller, but that's the website I was using. Thanks for watching. Take care.